squared, do we remember what we would classify this equation as? Remember last chapter we had all those different names for these equations? If it has degree 2, it is a trinomial, right? We've got our 3 terms there. What's our other classification that goes with this? Who's that? Someone said it, Matthew. Quadratic. Right? These are quadratic trinomials. Quadratic means we've got degree 2. Trinomial means we've got 3 terms. So end of yesterday, we worked with solving those 4-term equations. Right? We had those 4-term equations. We broke that up into like chunks of 2. We looked at the first 2 and the second 2. Okay, a little bit. Let's refresh our memories here. What did we do with each of those chunks? If we had, what was that? We did do the tree. What does the tree get us, Shadal? Great, thanks for the assist there. Greatest common factor, right? We look for those factor trees and we'd find our greatest common factor. So this is getting into a lot of what we're going to be doing during this unit is solving these quadratics. And we've already learned how to solve if we have those 4 terms. So if we can just break this up into something like we've seen before, we can solve the same way we did yesterday. So we have kind of a question we're going to ask to figure that out. So let's just start with a little example here. We'll get used to the question that we are going with. Does that sound good? Wonderful. Thanks for your response. We'll get into some math for the day. So starting with this first example, we've got an x squared plus 7x plus 10. Again, this is a trinomial. We've got 3 terms right now. We want to break this up into a 4-term polynomial. We'll kind of see how that works a little bit as we go on. But for now, we got to get used to asking ourselves this question here. We're going to look for a pair of numbers, 2 numbers, that can add to give us 7 and can multiply to give us 10. Factors of 10 that can add to give us 7, multiply to give us 10. So in this case, 10 has these factors right here. We've got these factors. Which pair of factors is adding to give me 7? 2 and 5 is adding to give me 7. This is the question that we want to get really familiar asking ourselves. Which pair adds to give us 7? So we're looking at our factors of this term here. Looking at our factors of 10. That's our term that doesn't have any exponents, it doesn't have any variables with it. Looking at factors of 10, and we're asking which pair adds to give us 7. In this case, we said 2 and 5. So again, we will go a little bit more in depth as we go on as to how this works. But when we pick 2 and 5 as those factors here, we're getting an x plus 2 here, x plus 2, times an x plus 5. A little bit weird how we get from one to the next, but we're basically picking those factors and we're creating our terms like that, which again, we've seen stuff like this before. We saw that chapter 7. We're picking those factors that give us that, and we are solving, we're getting our polynomial in a new form using those factors. So that's just kind of like really big overview where we're going today. I'm going to show you really how that first example works, and then after that we'll start getting more into like this trick here, this looking for those pairs of factors. So again, we want to break these up into those 4-term polynomials like we saw yesterday. This is a little sign chart that can help you if you need, but for now I want to get into just how this works, get that concept down first before we move into like trying to memorize tables. I don't think it's going to benefit you guys as much to just memorize a table if we don't see how it works first. So we got this first example, right? X squared plus 7x plus 6. And I want to ask that question that I want to get really familiar with. I want to look at my factors of 6. Get this statement right. If we want to look at factors of 6, I'm going to make a little chart over here for my factors of 6. Let's just start naming them. What are some factor pairs of 6? Heard a lot of Jacob says 3 and 2, so I'm going to do 2 and 3 right here. We want to think of these as pairs. 1 and 6. It's our nice easy one, right? You always got to remember 1 and whatever the number it is. Do we have any other factors for 6? No. You sure? Okay, good. I'm sure too. Just want to make sure that you're sure. Okay, so we've got 2 and 3, and we've got 1 and 6. These are the factor pairs that we've got. We do want to think of these in pairs. You don't want to mix these up because we need to make sure that they stay in the pairs that multiply together to get a 6. If we take a 2 times 6, that's not multiplying to get a 6, so we want to keep those in pairs. Now we want to ask, for this chart, which pair can add to get a 7? 6 and 1. Pretty straightforward. 6 and 1 can add to get a 7. 1 plus 6 equals 7. So, if we look at our quadratic trinomial that we started with, is it fair for me to rewrite this a little bit? X squared plus x plus 6x plus 6? Can I do that? Am I allowed to do that? What changed? We started with a 7x. We split that into x plus 6x. X plus 6x is equal to 7x, right? I take 1x, I add 6 more, I got 7x. And now this looks familiar to what we did yesterday. This is now just a 4-term polynomial. We have those 2 x terms in the middle. And now we can do the same thing that we did yesterday, break this up into the pairs and solve by finding what again? What are we finding? Solve by finding the greatest common factor. All right, time to practice what we did yesterday. A long time ago. What's our greatest common factor for x squared and x? 1 is for the coefficients, but then we take out a variable x. So if we take out an x, what stays inside this parentheses? It says x plus 1. Do we like x plus 1?
Yeah.
How could we check if we're not sure? We distribute, thank you Jacob. We distribute the x in. I take an x times x, that gives me my x squared. And x times 1 gives me my x, correct? I like that. What's our greatest common factor now for our next pair? 6x plus 6. 6. I guess we're good at this. Plus 6 here, right? What's inside my parentheses? X plus 1. What can we do from here? If we distribute, we're going to get back to where we just came from. We're almost getting there. Ariella, can you say that once more louder for us? The plus 6. Right? Since these inside the parentheses here are the same, we can combine these like we looked at the end of yesterday. We combine these to x plus 6 times x plus 1. That step was the trickiest yesterday, was combining these two. Remember, to do that, we have to have the same thing in the parentheses here. Right? The x plus 1 and the x plus 1 inside the parentheses has to be equal. Then we can take what's multiplied in out front and we can combine those into a new term. And again, if you do need to convince yourself of that, we can think back to last chapter when we did the distributing. We would take the x and multiply it by x plus 1. It's getting us this term, and we would take the 6 and also multiply it by what's inside those parentheses. Remember, those parentheses are grouping for us. So this is how we're going to break this up, right? This is the long way of doing things, but this is showing you where the math we're doing comes from. We're breaking that up into a 4-term polynomial by asking ourselves that question, looking at our factors and saying which pair of factors multiplies to 6 and adds to get 7. Kind of makes sense here also, right? When we multiply these two together, these constant terms multiply together. These are the factor pairs that we picked here. We picked 1 and 6. Those are what end up in these two binomials that we have here. Those multiply together to get us our 6. And remember, when we are foiling these, we take an x times 1 and an x times 6. That's what's getting us our 7x here. We break it up into the x and the x plus, or the 6x there, excuse me. From here, Olivia, we're going back to what you said, and we're solving this by setting equal to 0. If this pen will let me. When I solve and set equal to 0, what do I have to do? What's my next step? What's that, Matt? Make the x 0. Almost. We're kind of breaking this up again. Is that what you're getting at? A little bit? We're breaking this up again. We have that 0 product property. We're setting x plus 6 equal to 0. We're setting our first parentheses equal to 0 and x So that's the longhand way of doing things. The longhand way is breaking this up into those two parts. The shorthand way is just to take what we have here and put those in parentheses. If we look at this next example here, what changes between the last example and this example? What's new?
-6, 9.
Izzy said minus. Yeah, I heard the -6 over here too, right? We're noticing that there's a negative here. What we're not gonna do if we see a negative, no need to panic. We can look back at that chart that we used last time. So, I made that chart, right? What number do I wanna look for factors of? I wanna list the factor pairs of something. Of 9. Right, I wanna look for whatever this last number is here, the one that doesn't come with an x, doesn't come with an exponent. I wanna take that and make my chart. So I've got 9 here.
3 and 3.
You guys are getting right to it. We got our factor pair, 3 and 3. Done? 1 and 9, still missing 1 and 9, right? So last time we looked for numbers here that would add to give us 7. Right? We looked for factor pairs that would add to give us 7, but this time we have a -6. So when I look at this, I can insert negatives here if I need to get me to whatever that b value is. We call this the b value here. That middle term that goes with the x, I can insert negatives here if I need to. So is there a way I could insert negatives here that would get me to a -6, Emma? Yeah, if we make both of our 3's negative, a -3 plus a -3 does get me to a -6, right? -3 plus -3. So again, what I would do here, x squared minus 3x minus 3x plus 9. -3x plus -3x does get me to a -6x. So it's perfectly valid for me to rewrite this. And then again, we've got our 4-term polynomial here. What do we do when we've got those 4-term polynomials? Greatest common factor of which terms? Which terms are we looking at? What'd you say, Jeremy? Yeah, so the x squared, or we're looking at an x squared here. Breaking that up by terms. So we're looking for the greatest common factor in each of those. I can pull that out. For this first one, my greatest common factor, I'll give it to you as x times an x minus 3. For this second one, what do I want to pull out? What do you think I want to factor? Why -3, Jacob?
Because you have to make it the same as the other bottom.
We got to make those parentheses, what's inside, the same. So I want to make sure if I pull out a -3, you remember when we pull out that greatest common factor, we divide this by the greatest common factor. So if we pull out a -3, we divide -3x by -3. That leaves us with what?
X minus 3.
Leaves us with an x minus 3. See here, we still have that -3 times -3. That gets us a positive 9. So in this case, we can again combine these. And what does this one combine to? When we combine this? Okay, we have an x minus 3. Did I hear x minus 3 again?
Yeah.
Oh wow, my reading is not great today. X minus 3 times x minus 3. Do we see how that works? See how we're kind of splitting apart that middle term into 2 new terms and getting that into a 4-term polynomial like we had yesterday? From there we'd set equal to 0, we'd solve, we'd break that up. Why don't you guys try the last 2 on this page? The other thing I will say is you see we can take a shortcut here when we find our 2 factors at -3 and -3. Those just become right here, that x minus 3 and x minus 3. Right, same time with that first one, we had a positive 1 and positive 6. That was where we got our x plus 6, x plus 1. See how that's carrying over from start to finish? Why don't you guys give these last 2 a try? I would do at least one of them the longhand way so you see how it's actually working. The second one if you want to do shorthand and solve. without doing the whole middle step of like breaking up, finding your greatest common factor, you can just jump straight to those parentheses. That x minus or x plus something times x plus something. Give that a shot. I'll be walking around to help if need be. We'll come back together in a little bit. Thumbs up. Awesome.
Question.
Yes.
Would they have to be negative?
So this time they need to multiply to negative 15, and they need to add the positive 2. So you insert a negative here, right? And we insert like a negative 3. Negative 3 in the bucket. Does get some positive 2. Multiplies to negative 15. Yeah, Jake. So your one, what are we talking this? This should be x minus 3 times x plus prime. So we have 9 x minus 3.
Yeah.
This become one set of parentheses. X minus 3. So it's x plus 5. That's gonna go from there to there.
Oh, okay, that makes sense.
And then you said you can zero solve.
Okay, thank you.
Yeah, great. Ooh, so we gotta be careful which factors we take here. So we are looking for something that multiplies to negative 15 and adds a positive 2. So which pair of these can help get to positive 2? 3 and negative, or 3 and 5. Or negative 3, negative 5, negative 3, 5. So we've already established that it's 3 and 5. So now I need to insert a negative somewhere in here to make sure they multiply to get negative 15. And still add to give me a positive 2. So I like that you figured this